Hey, you're at Steve Tech. I'm Steve. This is part 2 of our rocker arm video. We just got done talking about the rocker arm stand, what style they are, that style of rocker arm from LS with a single stand like this to the old conventional stud mount, stud girdle stuff going on, and that more super rigid one-piece stand, and the extremely elaborate, probably not quite as, in fact it is not as rigid a stand just because of the way it's designed, but still works awesome. Now I'm going to talk to you about the actual rocker arm styles and what we're looking for. Okay, so let's go with our more conventional roller rocker. So this is that stud mount roller rocker. Roller fulcrum right here. I'm sorry, roller small end of the push rocker arm, and this typically you would see these in the old aluminum rockers. People say aluminum roller rockers. I mean, that's usually what they're talking about, is this style rocker. This is steel, but this would just be made out of aluminum. Goes on a stud, and is a better piece than a conventional rocker arm. Now, I don't even have a conventional rocker arm here, so the best thing I could show you is actually a non-roller tipped LS. Now, just pretend that this is, got the old conventional small block Chevy, big block Chevy, Ford rocker arm, but a non-roller tip. So what happens when this roller tip, non-roller tip, goes up, goes down, okay? So this thing's going up like this. All right, so this friction of this point of the rocker arm tip is actually moving, it's holding that, or I'm sorry, it's actually grabbing that valve stem tip and making it go forward and backward. So if you can see here, what you would actually see is as this rocker arm goes down, and we'll talk about the geometry here in just a bit, goes up, down, like this, okay, it actually sweeps. So it starts up here. I'm going to over exaggerate this movement. This is where it starts. At mid lift, as it's going down, it goes out here, and then as it comes around, it sweeps back. So it kind of sweeps in a circle. When it sweeps in this circle, it is, if you don't have the roller up here and a good freed up roller, it is actually making the valve stem tip go back and forth because of friction in that pad. So this little guy right here, as you're seeing this open, this thing goes up and down. It is actually forcing this valve stem tip backward and forward because of friction. All right, so that's why we want to have that nice roller tip. So stock rockers and even the stock LS rocker does have this problem. It does have a tendency to wear out valve guides because it's making this valve stem tip go like this, because as this goes up and down, it is pushing and pulling that valve stem forward and backward. That's why these things wear out wear out valve guides, typical LS stuff. And this is a decent rocker because it is have a nice fulcrum point through here. It is bolted down. It is better than the standard old system, but without a roller tip, these things will pick on valve guides. Just the nature of the beast. All right, so let's go over. So that is your basic roller rocker that was aluminum or steel, stud mounted, and most all these rocker arms are in general the same. Okay, so here is aluminum shaft mounted rocker arm. We have the 2 bolts that hold the shaft down to a solid stand. It might be super solid, like this one-piece stand where everything's tied together, or it might be individual stands, but it still is a better style rocker. Roller tip, roller fulcrum point right through there. So that's got a torn or little bearings through there, little needle and cage bearings. And this is actually sometimes a roller, sometimes it is not. as in there's a bearing in there. Jessels it's an upgrade option on a Jessel to have the bearing inside the roller tip. Most of the time it is just a hardened shaft with a hardened roller there, and in general that works really well, but obviously the roller tip is a little bit better. All right, then we would go to from this aluminum rocker arm like this. Now this is still a type of Mohawk rocker. It's real easy to see on the steel rocker what they're talking about in a Mohawk. It looks like it just has a single ridge all the way at the top. That's a Mohawk style rocker arm. You can see here, same thing. This is a roller bearing here. This is a roller tip out here. The wheel, it actually ends up being a little bit bigger, how you would tell that. And that has a actual roller bearing that is inside of it. So that's all to keep that valve as it goes back and forth on the valve here, like this. It doesn't pull and push the valve. It rolls on it. Okay, so that's keeping things nice. Now this Mohawk steel rocker arm is a really good rocker arm. No problems. I've used these on drag week style stuff. This is LS. Both of these are. This is the intake rocker arm for it. This is the exhaust rocker arm for it. Now, if we can do steel on all of them, it's just extra cost, but they have gotten significantly lighter. They're better. They have very minimal effect on valve train dynamics as far as flow or controlling the valve. They've gotten very good. That's why this one is this Mohawk design, because Jessel is trying to take a bunch of weight out of here to make it similar to the aluminum one, but have more strength like steel does. Now, the reason why we can get away with aluminum on the intakes and a steel on the exhaust is always the hardest to open, because the exhaust valve is opening up inside of cylinder pressure. Anyways, so if you end up breaking an exhaust rocker or a push rod, something like that, it has so much cylinder pressure because the exhaust didn't open up. All that cylinder pressure is stuck in the cylinder that the intake rocker can't open that great big diameter valve, that larger diameter valve. It can't open that, and typically will blow up the lifter wheel on the other side if it doesn't break the rocker. So if you can't open the exhaust, something happens that the exhaust doesn't open up, you can fix that whole side, but I just about guarantee you in all things that actually the intake side of that same cylinder is hurt, and you're going to have to figure out what's going on with it. Most likely will hurt the lifter, is the most common thing. Just totally blows up the lifter wheel because it can't open up underneath that cylinder pressure, that larger valve. So it's all a surface area deal. Trying to open up the big valve that big into cylinder pressure, like excessive cylinder pressure because the exhaust didn't open up, versus that little exhaust valve like that big, so intake valve, surface area. So think about it like the heel, high heel. Some chick with high heels, unit pressure. That pokes right through, hurts, like with minimal amount of pressure. This takes a whole lot of pressure in order to hurt you. Okay? So anyways, that's one of those things that you're going to pick up by that rocker arm deal. So now this is our SMX rocker. You can see it's not a Mohawk design. It's a different design. To tell you the truth, I don't even know what they call this design, but a lot of meat up through here for a real maximum strength. Here's your pivot point right here, push rod right here. This is your overall length. Okay, so now I'll show you something here in just a second, but this style rocker arm in steel is like bulletproof. I mean, these have been really good. Now we did have a problem with, there's a really high load area right here because of that fulcrum point. So this area right here gets a lot of load because of the rocker arm ratio. From here to here, here to here, dictates your rocker arm ratio. So like this is a 1/7 rocker. This is like a 1/7 rocker. See the difference in length in this thing from there to there? The same rocker arm, but that's length from here to here versus here to here. That pivot end back there. Okay, so that's why this rocker arm is really extremely heavy. There is some problems with valve train with Hemi stuff. There just is. And there's no way of getting around it. I mean, this is a really good rocker arm, really big pivot with bearings set up in it. Really big deal. I like that. But the overall length is just the nature of the beast. There's nothing you're going to do to get around that kind of thing. That's why we designed this with the wedge to be able to use this smaller, more compact rocker arm. And after we put a little more meat right here, the things look to be extremely durable. And when I said we had a problem, I mean, we're talking about something that would have had thousands of passes on it have a problem, because as this rocker arm is actually just running in its normal routine, every time this thing goes up and down, it is doing one cycle life. So imagine how many cycle lives this has running for 200-300 miles at a time. Even if they're low RPM miles, it's still going up and down. It's still going through the cycle. Not as harsh as a full boosted pass, but it still goes through a cycle life. And that's where we really see things live or die, is in these street drives. So these are your basic type of rocker arms: shaft mounted, non-Mohawk, Mohawk, steel. Why you're going to use a steel rocker arm on the exhaust at minimum, steel on both is preferable. And the good aluminums, you might be fine. You maybe run aluminum rocker arms on your stuff and you've made hundreds of passes, but you didn't make hundreds of passes and drive hundreds of miles and have all that cycle life. So there's nothing wrong with having that steel rocker arm, because that steel is a better material. They have made it light, and this is all scalloped out in there. You can see that. Like I said, this is only for my SMX, but you get the idea of that. This is a T&D style rocker arm. They lighten up the inside channel and keep the outside ridges here for strength, and it's a little bit narrower for the width. You can see that width for length. So I mean, this is a big stout stocky rocker arm. But anyways, that is the differences in rocker arms. What we recommend for rocker arms: always go steel if possible. Always go shaft mounted, because this adds a lot of rigidity. We already talked about the rocker arm stand and what that's all about. So now we're going to go over the actual geometry, and we talked a little bit about the roller tip rolling on the valve stem versus a non-roller tip dragging the valve stem with it, making it go back and forth. And now we'll talk about proper geometry and the setup of the rocker arm.